Well, a couple of things. Just by way of background, and thank you, Steve. I spent probably 3.5, I'd hate to say 4, but close to 3.5 decades chasing Moore's Law. How many of you are familiar with Moore's Law? Pretty good idea what it is, right? It's basically an exponential curve, says we're going to double, right? The number of transistors on a chip, which means you're going to shrink it, you're going to do all that sort of thing. When you do that, you get a curve that looks something like that. When this is, apologize for this right now, here we go. We got moved around. Now that curve actually goes up to 1960 something or other in the mid 60s. And it's been coming down this slope for a long time. But like anything exponential, when you go from 2 to 4, right? When you start to get towards big numbers and you start to multiply billions that then go to trillions, you start to get a different effect. And the effect becomes dramatic because what it does is it changes what we can do with our technology. And one of the things, so we all waited for voice recognition. We had to come down the curve. Had to get fast enough, be able to, right? Compute fast enough to be able to hear, translate, give us back the text. Right? All those steps. But we couldn't do it till we got down there. But now we're down there, but the other side of this is what's happening. Right? It's exponential. And what gets interesting here is this is flops per dollar. So this is a dollar curve. So Steve, it's a capitalism curve. It's looking at what's happening to the cost per gigaflop. Gigaflop. Now you're also going to hear petaflops, the latest Blackwell server out of NVIDIA. So here's Moore's Law, which dropped down our transistor size, brought it down, brought it down, brought it down. What's happening out the other side? Computing power is going up. Speed is going up. Density is going up. How many things we can do, how many computations we can do in a second. With that comes AI. With that comes the speed to look at huge amounts of data, compute the data, make sense of the data, and give us something back. Make sense? So when I started out in this business, most of us still had to take our shoes off to count to 20. Now we can just ask the computer to do whatever we want and give it whatever set of numbers we want to give it. And it'll produce the results. Everybody's familiar with ChatGPT? Right? One of the results of coming down another node. Now we go over to NVIDIA, and they just announced Blackwell, which is also a server, which is made up of their B200 chip, which goes in the petaflops. It's that fast. And so what it's allowing them to do is huge amounts of computation, and what you're seeing is 20 quadrillion calculations per second. Now, even if you take everybody's shoes off, you can't count that. Right? So it's that fast, and it's not stopping. It's not stopping, which is the point. It's going to keep going. As long as we can keep extracting more computational power out of the same dollar, it's going to keep going. Okay, so I first got involved in this a long time ago, writing about different things in technology. Written, 60, 70 articles before all of this came about. But in August of 2022, something came out called GPT, right? And DALL-E. So being the curious sort of prankster that I am, I wanted to see, well, what happens when you talk to it? And it is DALL-E. So I said, what would a human and AI look like to DALL-E, to the machine? Now, it has no emotion, it's not sentient, it has no whatever. It's just running on the probabilities of what it's going to do. Now, they've cleaned it up since then, but I think you'll find this interesting. This is what it gave me back. And I found that curious. Look closely at the mouth. Look closely at the eyes. It was almost a wink. No, I don't believe it's sentient. I don't think it's anything else. But this was really kind of like, okay, now you've got my interest. Now I got to find out what's behind all this. And I started to play in that space along with a whole bunch of other people that some of them I knew, some of them I didn't, some I've met since then. And it provided me with a great deal of interest in interesting things. This is one of my favorite quotes, if we can get it on the screen. There we go. Of all time, this is from Margaret Wheatley, and she says, the growing complexity of our times, and I think everybody would agree it's getting more complex, makes certainty about any move or any position much more precarious. Kind of a conversation we have all the time, right? Well, this could do, that could lead to this could lead to that. And in this networked world, okay, she's talking in 2003. She's already seen the spread of the networks, right? What's happening. By that time, by the way, the internet was up and running and doing pretty good. So, where information moves at the speed of light, that's how fast electrons move. So information's moving then. And truth mutates before our eyes, certainty changes and speeds off at equivalent velocity. Right? I think you remember for Pegasus, I wrote something called Ignorance is Accelerating. As this is moving faster than you, if you're not moving with it, what's happening to you? Ignorance is accelerating from that perspective. So this is courtesy of DALL-E 3. I gave it the quote and said, give me an image. It gave me that image. Very interesting. It's dealing with complexity, it's morphing truth, it's having fun, right? Pretty interesting illustration. But that's what it's doing to us. It's taking our ideas of truth, turning it upside down, and making it much more difficult all the time to, right, discern what is, what isn't. And there's something, I think, as a takeaway for you that I would like to leave you with for sure to take away, is the word provenance. Data provenance. Where did it come from? Has it been corrupted? Do I know the source? Right? Who was the source? So provenance is going to become kind of the new gold coins of the realm, if you will. Your data provenance is going to mean something. You're going to see, people say, what's the value of cryptocurrency? Well, some of it is, if you have a token attached to data, that gets interesting. Now I have provenance with the data, right? And I can guarantee it. All right, now we're going to see what coming down that curve does. Here you are on a train in Japan, maybe China. Want to see it again? Now take a look and you're going to see the person doing the photographing. There she is. There isn't one pixel on there that's real. There isn't one pixel on there that hasn't been generated by a machine. And it did it off of a text. Okay? That's what's coming. That's where AI is today. So, how did we get there? Well, we had fire, we had farming, we had printing press, steam engines, electricity, cars, airplanes, nuclear, computers, CRISPR. But is this one a point of departure? Is this a point of departure? Is this different than the rest of the major things that humans have done? Some people say yes, some people say no. It's an interesting conversation to have. It's an interesting dialogue. I don't think we'll know until the computer lets us know. Here's an internet minute. Now, if you study this closely, The numbers are mind-boggling. Hopefully you can read that. 625 million videos watched on TikTok in 1 minute. That means since I've been talking, there's been over 3 billion. That's the power of the numbers here. That's the computational power that's out there. 3.5 billion Snapchats per minute. Per minute. 44 million people viewing Facebook live streams. We could have done that with this, live streaming the video, Facebook, followers, all that good stuff. People do it all the time. So you get the idea. There's a lot going on. And it's a huge amount of data. It's a huge amount of information that AI has to play with. So you say, well, what do they do with it? Well, that depends on what you give them. So if you give, they get. Signal. How many of you have seen Signal? You on Signal? I'm on Signal. Right. Why are we on Signal? It's end-to-end. End-to-end encryption, right? It's not going anywhere. Somebody have to, unencrypt, break the code. The only personal data Signal stores is your phone number. It makes no attempt to link it to your identity. Now that's a good news, bad news. If you're a corrupt person and you have evil thoughts, it's a nice place to hide. On the other hand, if you want to have confidential conversations with your children or your friends or a project, you may want to use it. If you look at iMessage, takes your email address, your phone number, your search history, where have you been? Why do they want to know your search history? Maybe sell you something? And the device ID. Well, with the device ID, now you know a whole bunch of other things, especially if you're triangulating. Where are you? Right? Doesn't mean they're following you, but you could figure it out. You go to WhatsApp. How many are on WhatsApp? Right? I like it. It's got a lot of things you can use. Doesn't ask too much of you, but it asks quite a bit. Device ID, user ID, contacts. Well, that's interesting. My contacts, really? It asks. Doesn't necessarily mean you give it to them. Product interaction. Oh, what are you looking at? What are you playing with? We'll look over your shoulder. Crash data, performance data, payment info. Did you buy anything when you were here and went over to another site, or somebody sent you something and you clicked on it and went and bought it? Now let's go to the big dog, Facebook. The world just changed. Big time. This is the amount of information that's going through Facebook, to its advertisers, to its partners, to whomever. And it's a huge amount of data, a huge amount of information. If you've ever been on Facebook, you're profiled. Your children are profiled. It's all there. Now, does that mean that we have some people that are manipulating and using, and we can go off into all that other stuff, fantasy land, I call it? But there are people that could abuse it, could use it. TikTok's kind of in the same category. So when you have all that data, you start to use something called deep learning. Now, I'm not going to go into detail because it gets a little bit complicated technically, what it is, how it works, all that. But it's fairly simple in the sense that you have something that you compare to, and you run the inputs of it, and it keeps filtering and going, nope, that's not it, that's close, yes, that's closer, no, that's closer. Yeah, that's even better, yes, no, yes, no, yes, no. Finally gets there and goes, oh, those match. Now I know dog from cat. Right? It just did it mathematically. It didn't do it, some conscious effort. It was mathematics. It just said, this is closer to that than that is. Go to the next one. This is closer to that one. Go to the next one. It's the easiest way to describe it. I'm making it over simple, but that's... So what can you use it for? How many do you have on your security on your iPhone face recognition to get into an app? I do. That's all I use. I'm not going to remember all that stuff. When I go through and change them all, I don't want to have to do that either, so I just have them look at my face. Well, It's using deep learning. Saying that's Michael. If that is Michael, then this opens. If it's not Michael, it doesn't open. Right? Take your sunglasses off, right? Whatever it is. If you look at things like optimizing credit score, now we're starting to get into that other data, and we're starting to play a little bit closer to the bone here about what's going on with this individual or group of people. So you get the idea. When you can do this where you're saying this is a match, then I can go through all that data, look for those matches, and now I've got my answers. And that's called deep learning in a simple sense. So deep learning is interesting in that it's easy to analyze huge data sets. Right? Huge data sets. Think back to that 1 minute. How much data is being generated? There's no way a group of people, a human mind, can even begin to process that. And that's the biggest step that AI has over humans. The amount of information that can be processed. But it's difficult to build concepts and take creative decisions. Just as well, mathematically this all relates, and I can predict what the next thing is based on the mathematics. It's not going, oh, well, I wonder if. It doesn't have a wonder if. It has a locked-in set of algorithms. So that's, again, to try and separate the two. Human brain. It's hard to handle big data sets, but it's easy for us to take creative leaps. And that has good news and bad news to it, right? What's the latest one on the, what's a creative leap that you can think of? An example of a creative leap. Conspiracy theories, those come to mind. That's a creative leap. Right? And what do you do it in? The absence of information. Or partial information that you can fill in with other information, misdirect people, etc. So it's easy for us to do that, take new concepts and do it on very little data. So part of this is extracting from the big data, little data that you can act on as humans. Go ahead and use the machine, go parse it, grab it, but bring back something that I can use. So the most often used for this is commercial. Sell you something. Right? Take a look at your social taste. Do a few other things. Now, I've hidden a couple things in here unintentionally, but intentionally. So if you look at that first one on the left there, that's really sort of a standard algorithm. Look and see where people are, place them in a grid, et cetera, right? Now, if I go from there, I go one step further into vectors. And I'm not even going to begin to try and explain vectors and vector analysis. But what it does is allow us to find the relationship between things. So in this case, it's hard to read up here. I realize that. It's even harder for me to read. But we can group people based on their tastes, by what they're interested in. And once I do that, I can sell them something. Well, this group is interested in this, and this group is interested in this. And I can separate those. And oh, by the way, if I'm Facebook, I can sell that group off to that set of suppliers and promoters, and I can sell that off to those. So it works pretty seamlessly, pretty simple. Not that hard when you're getting that much data all the time. What did you look at? When did you look at it? So now there are other people out there, and this happens to be a group that I'm familiar with, like them a lot. This is a slightly more sophisticated use case that might give you some pause when you're considering your information sources. All right? So we'll go over and we'll take a look at the narratives here. See if this is going to work for us. It did. So this narrative is about the amplification of Chinese and U.S. conversations. China diplomacy overview. What's happening? What's going on where? What you see is the yellow line is saying where it's originating, and the red is where it's ending up, the target. Then it's looking at the different types of amplifiers that are there. What are the articles? Who are the ones promoting it? Where do they source it from, et cetera. So what it allows you to do is trace back in a narrative battle, where did the narrative start? Who are the targets of their narrative? How did the narrative continue to evolve? How does it get pursued? So that gets to be very interesting, and especially when you start to want to unbundle misinformation, or who's really got a, skin in the game, if you will. So I can go over here and I can take a look at, let's see if it'll do it for me here. Yeah, it won't. There we go. So it says New Delhi, Washington, 2 items. One was the Havana Syndrome piece that came out, right? So it's saying, well, it started here, it went here, and now it's going here. So it looks innocent enough at the final stage, but the beginning stage is what you really want to know. So we'll go back into here. I think it'll let me back. Yeah, it did. So that's another way of, again, parsing the data and what's going on and sort of trying to get truth separated from lies, if you will, or at least find out who's controlling the narrative, or if you want to control the narrative, what you might do as well. That gets interesting too. There are numerous technologies out there. Neural nets, that's basically machine learning. It just looks at it. Deep learning, we went through. Reinforcement learning, that's where the human gets involved and starts to take a look and says, oh, well, let's put a little more weight on this than on this. That's the secret of algorithms, by the way, too, that are carefully guarded by all these companies. That relationship between word 1 and word 3 has a mathematical relationship, and it can change based on the context. The humans know that, the machine doesn't. It just knows 1.161 or some other number. Computer vision. It's interesting, people go, well, we'll never have self-driving cars. They're not as good as humans. Really? A CCD camera has 4,000 times as fast as you are in terms of recognition. Natural language processing, the ability to just put anything in, talk to it, and have it come back. That's what that is. Understanding, oh, you said this and you were that. How many of you used any of the GPTs or AIs or chatbots or any of that, right? You usually give it a persona. You are a, and then have it look. Well, you just gave it a way to go to here. Natural language understanding. And then large language models, which everybody's heard about, that's what GPT is. Huge amounts of data and information that we can go search. The applications, robotics, expert systems, right? Recombination engines, speech and facial recognition, which we all are aware of, autonomous agents coming to a pocket near you, yours, your buddy. Going to go out there and do everything that you would do it for you. Although making toast isn't on top of my list, but you get the idea. You'll be able to do something with it and use it. Generative systems, text to image. That was basically that train. We're already there. Going from text to the image to the video now. Those all lead to what's called Web 3.0, spatial web. So now we're going to go and add another dimension. We're going to look at the relationships in 3D, not just 2D. And that's what's coming next. That's where your virtual reality plays. That's where all those things start to play. They're already here. They're just not distributed. So here's a cheat sheet for you. Lots of good things you can play with. Large language models generate human-like text based on training and data prompts. Pretty simple, pretty straightforward. Chatbots, content generation, ChatGPT is the obvious one. Natural language processing, NLP. It's between computers and human language. It's like sentiment analysis. You know, how much of this, how much of that. So you start to look for those numbers that you can then bias your algorithms with. Text summarization, language translation, all of those things. Machine learning, neural nets, neural layers. You can learn from the data and improve the performance, keep tweaking it, get it better and better, faster and faster. Deep learning, we talked about that, reinforcement, and computer vision, interpreting visual information. Now that starts to get very interesting when you start to get to the emotional side of things. It's one thing to read a face, it's another thing to know what the face is feeling and doing and thinking, and then be able to predict that. It won't be a lie detector test anymore. It'll be you walked into the room and opened your mouth. Done. So when you put the two together, you get some interesting synergies, and that's really what this is about. So here's the definition. Collaboration is a synergistic relationship between human and artificial intelligence technologies where each element complements the other's strength to achieve a greater intelligence and problem-solving capability. It isn't about one running over the other, right? It's about how do you make it work together. Now, there's some trust issues that fall in there. There's some boundary conditions. There's some equally shared values. There's a whole bunch of other stuff that comes into play in order to make that really work. But if we can take some of those out of the equation, which right now we're doing, we can look at very specific things: enhanced problem solving, knowledge acquisition and dissemination, improved decision making, that's what I'm after, enhanced learning and training. Amazon can train its warehouse people on virtual reality. They do it now. There's a classical use of the two, and creative exploration. Being here now, medical diagnosis, I think a lot of you have heard about that already, the accuracy of that, how good it is. The radiologists are going, right? But it still has to go through them, which is the right thing, and then they get used to it. Financial forecasting. Quants have been around a long time. But people start to look at what are the trends, what are the patterns, what are the, right? Behavioral economics is going to start to play into that one a lot, I think. Scientific research, obviously looking for drugs, cures, different things we can do with tissues, et cetera. One thing to remind you of also is how many people think we're going to have long-term space exploration? How many of you think that the passengers will survive?
Passengers will survive.
No. That's one of the biggest problems that we've got. Right? Space is not a friendly place. Zero gravity, microgravity, cosmic rays, etc. They do funny things to your DNA. Okay, here's some fun. Now, this is an eye test chart, and I apologize, but it's talking about nodes. This is a protein. Right? And it's looking at the interaction between proteins and amino acids in a particular cell. It captures the mathematical network structure of protein interactions. There's a language in each one of these, how they interact, how that protein interacts with another protein and with itself. That's the same thing we find as the deeper we go. What happens, we find that the world is messy, right? It's messy when you get down to it. So this is very interesting about how far we've come and why we're getting progress on multiple fronts. It's that huge amount of data, the ability to look at relationships, understand how the relationships are changing in relationship to each other, and then figure out where we're going to intersect it. And hopefully we do it at the right time and place and it doesn't hurt us. So a friend of mine that I work with named Michael Jackson started a company called Preempt.life. He also was responsible for Shaping Tomorrow. And I'll show you that in a minute. But looking at scoring human individual intelligence and artificial intelligence and then combining the two, we're already at a point where the two are better than either one. So there's, there's a hope side to this as well as the, oh boy, it's freaky on this side. It's way beyond us, yes, but there's things we can do to make it work. This illustration, by the way, was from DALL-E 3. And I just asked it, what does human intelligence and artificial intelligence look like when you combine them to a 12-year-old? And it was interesting, the different things that it used, smiley faces and all the stuff that they would be familiar with and respond to. Right. So a little in between. We'll do it one more time. Not one pixel is real. Okay. So combining human intelligence and artificial intelligence to look around corners, that's really what we're trying to do. And this is the advertising part of this, but it is a little bit, some of these things nobody's ever seen before. The first time to see them in public, or at least have them promoted publicly. So I'll say that in advance. So here you have, how do you combine them to get to making better decisions about the future? Well, one thing you want to do is build foresight. Begin to look, what's the research look like? So hopefully our computer works well today and we can go look. Speed kills. So this is called Deep Dive. And what Deep Dive is years ago, the people that were involved in the Human Genome Project figured out how to create relationships between things with very little information, and then turned that into a search engine. And this search engine is dedicated to journals, just all the journals like Wiley and everybody else. And you can go in and you can look at a subject and bring something up, and it'll tell you the research. It'll bring up whether it's available to download, whether you have to pay a price, et cetera, but you can look at it. So I pulled one up here to look at. Here's harmonious hydrogenated catalyst. So I can start with a very small thesis and I can go right to the bottom of who's actively researching, what are the most recent papers. I can get to the real data provenance. I can get to this is what was said at the literature level peer reviewed. So that's sort of a step one. Step two might be, well, I wonder who's doing work on that. Who's doing research? And who's filing patents? So this is a group out of India that I work with that is looking at the USPTO and other patent offices and develop their own AI to go and take a look and scrape those patents and organize them. What do they look like by technology? Who are the most prominent players? Who's doing what where? So we can take a look at that. And here it brings them up. Heterogeneous catalyst for hydrogen generation from formic acid. Devices for generation of hydrogen. You get the idea. Here's the number of people or countries that are playing it. Here's the number one player. It goes on and on. I can go deeper and deeper. I can get to the patent. I can get to the claims. I can show you, it's just another, I'm just trying to tell you what vehicles are out there. So I've now gone from, people are thinking about this. People are doing something about that. What else might they be doing? So we can go over here, and we can find some interesting relationships. So here we have bio-inspired hydrogen catalysts. Took it one level further. So off of the research and patent data, started to narrow it down to go after, that's interesting, what's going on in this particular space, and what are the drivers? And I apologize, this is not quite as sharp as I'd like, but you have concepts, innovations, discovery, all kinds of activity. But here's something else interesting about this particular site, is I can do a SWOT analysis. I can do emerging technologies. I can look at concerns that there might be around the technology and again, use that vector relationship to look at how that expands or where it goes. I can look at paradigms, I can look at outlooks, resources, regions, and divide it all up again. I can go deeper and get more and more and more. Well, then the guy that invented that one sold it, started another one. He started out, so this is Preempt.life, and Michael Jackson started out about 13 months ago, started to put together a group of engineers, about 9 engineers looking at prompts, look at GPT, started to figure out, having done this, because 20 years earlier, he'd already built the first kind of web crawler, et cetera, to do analysis, had already been familiar with AI. So now I can pull up, I'm not going to take you to the website, but hydrogen fuel catalysts. This is a 240-page report out of GPT-4. Took about 3.5 hours to run, so you know how fast it is. So what he's done, with advice from me and a whole bunch of other people, is take about 300 different versions of foresight planning and build them into the prompts and inquiry, and give us back a report, an extensive report that I can then turn around. You can just get an idea from the present, the future, the players, the viewpoints, the cultures, the lifespan of it, the locations, the technologies. You get the idea. It's extensive. Responses, the what ifs, the metrics, forecast, investment. Also gives us a set of assumptions to review. So we built that in. We built in trans-contextual comparisons. So this is people that have spent, most of their lives looking around corners using GPT to look again. But now as you build that around the corner thing to look at what can we do, the whole idea is you take all of this, you add the human, and you start to hopefully get better decisions. That's kind of the goal. So we can reimagine futures, we can be better informed in our decisions because you can build the pile and then you can put it through the human combination and come up with a better decision. There are other people out there coming along as well, tons of them. Right? By the way, if you want to have a fun conversation, go to pi.ai, pi.ai. It's friendly, it's fun. I have a friend of mine that goes between Rochester and Minneapolis pretty frequently, puts on Pi, has a conversation all the way down, all the way back. Yeah, that gets interesting. So we ran 250-page report, took 4 hours. Eventually that's going to come down to 15 minutes. Think of what that gives to us as humans in terms of knowledge. So if you look at it, human and artificial intelligence provides advanced strategic foresight. We can start to look around the corner maybe. Those gives us some forward and decision intelligence capabilities, something humans have always wanted. Be able to look forward with some degree of intelligence. And hopefully we find more options and insights and we make better decisions. So this is the way that we look at it. Human intelligence plus artificial intelligence allows us to look around corners to help you make better decisions about the future. And as a company, of course, keeping all of our eyes on things so you don't have to. As a closer, coming to a misinformation site soon.
Mike,
Yes. Thank you, by the way, that's it.